So let's start. This should be final, no more problems. Oh no, I can only use black for free edition. Anyway, let's start. We have integral of 6x to the fifth minus 18x squared plus 7 dx. So if this is the case, I need to integrate them separately. So this would become, so I'll distribute dx so that this would become integral of 6x to the fifth dx minus 18x squared dx plus the integral of 7 dx. And if we go back to our notes here, to our guide, that if the integral or the given problem is integration is x to the n dx, meaning we are dealing with exponents, so that's just equal to x to the n plus 1, meaning we will add 1 to the exponent and divide that by n plus 1. And of course, plus c. So there is a notice here that n should not be equal to negative 1. Because if n is equal to negative 1, the denominator will become 0. And if the denominator is 0, so the answer, when you divide any number by 0, the answer is indefinite. So we cannot solve it. So we will have problems in our solution. So we'll have to avoid not having an n equal to negative. But anyway, this is not our problem yet, since the topic here is indefinite integrals, meaning there are no what we call the lower limits and the upper limits or values that we need to solve. By the way, integration is just summing up all numbers. However, in summation notation, we need to add numbers individually, 1 plus 2 plus 3 plus 4 and so on. But in integral calculus or integration, it's just like a shortcut. Now, say for example, you have here a limit, you just need to substitute this limit to the value, then you'll easily get the summation of all those numbers or values. So that's the advantage of integration. So it's like a shortcut to summation. Now, wherein when we sum up using summation notation is we have to add them individually. But if you want a shortcut, no, we'll use integration. Okay. I think I need some music. I hope my PC will still be able to function well. YouTube.com. Let's have a background music, but let's tune it a little. Music for studying. Okay. Not live. How about this one? Jazz. How about this?
They're coming straight.
There are ads.
Trust me, I've got nothing.
Skip. Then we'll just lower the sounds. Okay. Okay, I think that's all right. Now let's continue. I'm just solving one problem, but it took a lot of time. Oh my, that's math for you. So here, now let's go back to our guide here. And again, there is another rule previously that if there is a constant value, now we'll just have to move out the constant here. So this will become a integral of dx, which would result to ax plus c, because the integral of dx is x plus c. Then let's start solving the S1. So just like this, we'll have to move out the constant outside the integral sign. And what would be left is x to the fifth dx. Next is the other one. We'll have 18 integral of x squared dx plus 7 integral of dx. So as you can see, we now have this form here, right? And also this one. So n here is any number, so the exponent and any number. And this one here is just like this one. Integral of dx is equal to x plus c. Then let's move to the next one. So this will become 6 times. So based on this, we have x. We just have to add 1 to the exponent, but divide it by the n, which is 5, and plus 1. Then supposedly we'll have to put c, but let's put here c in the last portion after we integrate all of these numbers. And this will become 18. Then still x squared, so you have here x to the n, so that will become x 2 plus 1 over 2 plus 1. Then plus, you have here 7. Then the integral of dx is x. Then we'll put plus c, because c again is any constant. So if we will add this one is plus c, supposedly another plus c, another plus c, but it's in the rule that we'll just have to use 1c. So simplifying, we'll have 6 times x 5 to the 5 plus 1. So our exponent will become 6, and divide it by 5 plus 1, which is 6, and subtract it by 18. Then you have x to the 2 plus 1 is x cubed. Then you have over 3 plus 7x. So we can remove the parentheses since it is understood that 7 is multiplied by x. Then the plus c. We can still simplify this. We can divide 6 by 6, so that is equal to 1. And what would be left is x to the 6. And we have minus. We can have 18 divided by 3, since 3 is at the denominator. So this is equal to 6x cubed. Then we have plus 7x plus c, which means this is now the simplified version or answer. So let's check the problem here. You have, again, the problem is 6x to the 5th minus 18x squared plus 7 dx, or derivative of x. So the answer, our answer here is x to the 6 plus 6x cubed plus 7x plus c. So let's check. We need to show the solution. So, and we got here x to the 6. Okay. So I think this one should be... Okay, anyway, yeah, you have there x to the 6 minus 6x cubed plus 7x plus c. Then we got the correct answer. Now let's try this one before we'll go back to the previous page. So let's try this. So let's move. Move and move and move. Okay. So It's this. So let's solve number 2b, or number 1b, sorry. Erase, erase. Then that's 1b. So we have solved 1. This is 1a. Guess. So this 1a. I think I need to use circle instead. Oh. That's 1a. Next is we're going to solve 1b. Right. So 1b is the integral of 6x to the 5th dx minus 18x squared plus 7. If you noticed, the dx is placed here, which means this portion here, we don't need to integrate this portion. So only this one will be integrated. Unlike earlier, the given problem earlier, that we need to integrate all of these three, since the dx side is at the last portion. Commonly, if the integral portion is written at the beginning and the derivative sign is written at the end, so that would mean all of those in between should be integrated. But I'm comfortable if I write here this one. I'll write in this form, because this would give me an idea that I need to integrate all of these three. So again, we don't need to integrate this part here, since the integral, or this number, is in between the integral and the derivative sign. So, I think this would be much easier. So the result would be, again, we move 6 outside the integral sign, and any constant, when we say constant, a number will be moved outside the integral sign and be multiplied later on. So that's x to the 5th, derivative of x, minus 18 x squared plus 7. Then we have 6 times, we now integrate here, this is x to the 5th plus 1 over 5 plus 1 minus 18 x squared plus 7. Then we have 6, then x to the 6th over 6 minus 18 x squared plus 7. Cancel that out. Then we'll have x to the 6th minus 18 x squared plus 7. So that means the integral of this is x to the 6th, 18x squared plus 7. So let's check if the solution is correct. I forgot. So we should have plus c. Sorry about that. And it's a requirement to have plus c. So we can write plus c here at the end. Okay, so that's x to the 6th plus c minus 18x squared plus 7. So again, I have found this problem in Paul's online notes. So if you want to practice, you can do the same way. Hello, Ricky, Shamsori. Next, we'll solve number 2. So we have for number 2, a. So let's have number 2a. That's the integral of 40x cubed plus 12x squared minus 9x plus 14 dx. So again, sometimes I prefer to write in this form, just like this, because that would tell us that those values in between the integral sign and the derivative of x should be integrated. Hello everyone, Casas B, Montisi, Heart, Jared Azir, Bounce, Larry Malik Dem, J Star, and Buddy. So right now I stopped playing games. No, I usually play games while streaming while streaming, but today I'll have to review. So hello Trader Pro and Captain America, Black Mamba 24 Lucas. Anyway, let's go back. So we have this one. So we have to take note of the rules, especially these first three, because since these are the given um, problem problems. So we have integral of 1 dx, or just dx, is equal to x plus c. The integral of a dx, again, we'll have to move out the constant so that it will become integral of dx. And this form now is just like this one. So the result will be a times x plus c. Then the last one is an exponential, integral of an exponent. No, then we just add the exponent by 1 and divide it by n plus 1. And we should not forget c, any constant value. So let's start here. So again, we'll integrate them one by one. So this will become 40x cubed dx plus integral of 12x squared dx minus the integral of 9x dx plus the integral of 14 dx. So again, the second rule is to move the constant values outside the integral sign. So this will become 40 times the integral of x cubed dx plus 12 times the integral of x squared dx minus the integral 9 times the integral of x dx plus 14 times the integral of dx. So let's check number 2. So again, what I like here in Paul's online notes is that I can see the answers, though there are no detailed solution. But I guess if we arrive at the same answer, then that would mean my solution is correct. Probably there is a high probability that my solution is correct, since we get the same answer. And aside from that, if we don't have the same answers, I can review my solution if I'm on the right track. So let's continue. So this will become 40 times, so we go back to these properties that the integral of x raised to power n dx is equal to x to the power of n plus 1. So we just need to add the exponent by 1 and divide them by the exponent plus 1 plus c. So c. But if there are a lot of terms, we can add c at the last or in the last part. Okay. So this will become x to the power of 3 plus 1 over 3 plus 1 plus 12 times x to the power of 2 plus 1 over 2 plus 1 minus 9. So this is x. So if this is x, that means x has actually a power of 1. And we can use this property again, to solve for the integral of x dx. So this is now x 1 plus 1 over 1 plus 1. Then we have 14 times x, because the integral of dx is just x. Then we have here the integral of dx is just x, and we will have plus c. Okay, so that's plus c. Then we can simplify this further. So we have 40, and you have x to the 3 plus 1 is x to the 4th. And 3 plus 1 is 4. So commonly, the exponent and the denominator would be the same, since based on this property, so the n plus 1 will just, we will divide n plus 1 here, this term. Then we'll get 12 times x cubed over 3 minus, again, I'm using right now whiteboard, shareable since it's free to use, but it's freemium, I think, because you need to, or they just want me to sign up so that I can use all the other features. Right now, I can only use the color yellow. I cannot use black or any other color, but it's okay. I can still write. Then these problems were taken from Paul's online notes, and also some theories taken from here, by juice or B juice, or properties. Okay, let's go back. Then we'll have 9 x squared over 2 plus 14 x, then plus c. Again, we just have to add c. So here we have 40 times x to the 4th over 4. Since this is multiplication, we can divide 40 by 4. So what is 40 divided by 4? So this will become 40 x to the 4th. So I'll just write this one so that I will remember or recall why certain numbers become that. So you have 12 x cubed over 3 minus 9. Okay, that will be 9 x squared over 2 plus 14x plus c. So I can still simplify this portion here. So 40 over 4 is 10. So this will become 10x to the 4th. Same with the second term. 12 over 3 is 4. So that's 4x cubed minus 9 over 2. I can write in this manner or just like this. I won't change, but they're just the same. Then plus 14x plus c. So this is now our answer for 2a. Now the integral of 40x cubed plus 12x squared minus 9x plus 4 dx, or derivative of x. So let's check if we got this correct answer. So again, the advantage here in Paul's online notes is that I can check if my answer is right or wrong. Let's check. So we have 10x to the 4th, so this is correct. 4x cubed, correct. 9x squared plus 14x plus c. So my answer is correct. Now let's proceed to letter B, 2b. So 2b is 40x cubed plus 12x squared minus 9x dx plus 14. So we have to remember that we will only need to integrate those values in between the integral sign and the derivative of x, which means we'll only need to integrate these. So 14 will be left as is. So that would be, again, since these are the terms that we need to integrate, so we can integrate them one by one. So what will happen is that we can rewrite this as integral of 40x cubed dx plus the integral of 12x squared dx minus the integral of 9x dx plus 14. Then we'll go back to these properties. So, but before that, we'll have to move out the constant values or those numbers. We move them outside the integral sign. So we will have 40 times the integral of x cubed dx plus 12 times the integral of x squared dx minus 9 times the integral of x dx plus 14. Then follow the properties here. So when integrating x with the power or x dx to the power of something dx, so we'll just have to add 1 to the exponents. This will become x to the power of 3 plus 1 over 3 plus 1. Then plus 12 times x to the power of 2 plus 1 over 2 plus 1 minus 9. So again, it is always understood that x has a power of 1. So that is x 1 plus 1 over 1 plus 1. Then we should not forget c. So it's in the rule that when integrating, the last should be plus c. But do not forget plus 14. So since it's part of the given. Then proceed to integration. So we'll have 40 times x to the fourth. So that since that is 3 plus 1 over 4 plus 12 times x cubed or x to the 3 over 3 minus 9 times x squared or x to the power of 2 over 2 plus c plus 14. And we can simplify because we can, since this is multiplication, so that's 40 divided by 4 or 40 times 1 over 4, so that's equal to 10. And multiply x to the fourth plus 12 divided by 3, so that's 4 x cubed minus, or we can rewrite this as 9 over 2. It's just the same if we write 9x squared over 2. So that's fraction plus c plus 14. So this is now my answer, and we will check this with Paul's answer. So Paul said this is 10x to the fourth, 4x cubed minus 9 over 2x squared plus c, then plus 14. So we got the correct answer. So our solution is correct. All right. By the way, the topic is under indefinite integrals. So when we say indefinite integrals, meaning we are summing up numbers from negative infinity to positive infinity. There are no values in the integral sign. Commonly, if we have values here, for example 0 to 2, then we will need to substitute these values of 2 to our x. But I think that would be this, there will be problems in the definite or finite or definite integrals. And that is also found in Paul's notes. So I think it's, yeah, definite integrals. Commonly, definite integrals are used to solve for the length of a line, an area of an irregular shaped curve, or any, it can solve an area of any 2D surfaces. And even 3D surfaces, I think that will be using double or triple integral. I forgot. But anyway, we're having a review right now. So let's just follow the problems given by Paul's online notes. Right, I think there is no need to solve. No, we can solve directly this one since Paul just wants us to take note of the location of dx. Again, we need only the terms in between the integral sign or the integrand and the derivative of x or dx should be integrated. Those outside them will remain as is. So for the sake of solving, so let's just write this one, and I'll just write directly the answer since we have already solved here in the above portion. So we'll have integral of 40 x cubed plus 12x squared dx minus 9x plus 14. So again, we'll only need to integrate these two terms. So this will become 40. Let's answer them directly since we already know the answers. So the integral of 40x cubed dx is 10x to the fourth plus the integral of 12x squared dx is 4x cubed minus 9x plus 14. So this should be the answer. By the way, if you are familiar with differential calculus or differentiation, so the integration is the reverse. Now, when we say differentiation, we're gonna break them down into a very tiny piece, what we call dx or the change of x. While integration is summing all of these pieces. After breaking, we sum them back using integration. We break them using differentiation. We sum them or put them together using integration. So let's check the answer of Paul. So that's 10x to the fourth. Yes. 4x cubed. Oh no, I forgot to write c. So I need to erase this. So please do not forget to write plus c. So my teacher is somewhat strict, so I might get some deductions or even a wrong answer. So this is 10x to the fourth plus 4x cubed plus c minus 9x plus 14. So a plus c is actually any constant value that we have to add in our equation. In higher mathematics, I think there are solutions on how to solve for this one, for the c, or the constant value. All right. Then let's go back to number 3. Let's now proceed to number 3. Paul has given us 7 items here. So let's have number 3. Oh, number 3. Oh no, number 3. Okay. So problem number 3 is the integral of 12t to the 7 minus t squared minus t plus 3 dt. Again, we have to integrate terms or items in between the integral sign and the derivative sign. And do not be confused if the problem will have other variables, because any variable can be placed in the integrals as long as the variable here is the same with this d of dt, or the derivative derivative of t. So in our previous examples, that's derivative of x. Here, this is derivative of t. Then let's solve. So that would mean the properties given previously. So we have here in the previous slides, we have dx. So instead of dx, we will use dt. So that will become the derivative of dt, or 1 dt, is just equal to t plus c. Then the derivative of a dt is equal to a times integral of dt, or just a times t plus c. Another is, again, since based on the given, we are only given we are only dealing with the first three characteristics or properties here. Then the last one is the integral of t to the power of n times the derivative of dt of t is equal to t to the power of n plus 1 over n plus 1 plus c. So again, it's a must to put c if we are dealing with integration or indefinite integration. Hello, Joella. Thanks for the react. Please follow me if you want to see more videos from me. So let's start. So now, again, we can rewrite this as integral of 12t to the 7 dt, then minus the integral of t squared dt minus the integral of t, derivative of t, plus the integral of 3 dt. Afterwards, we will take out or move out the constants. So this will become 12 times the integral of t to the 7 dt minus the integral of t squared, since there is no constant value beside t squared. Then we'll have integral of t dt plus 3 times the integral of dt. Next, proceed to the integration. So we'll have 12 times t to the 7 plus 1. So take note of this property. So n is any number. So n again is any number. So that's, for in this case, this is 7. So that would be 7 plus 1 minus t to the power of 2. So add it by 1 over 2 plus 1 minus t to the power of 1 plus 1, since again t, as understandable, it has a power of 1 over 1 plus 1 plus 3t, and we should not forget c. Then we can simplify them further. So this will become times t to the 8 over 8 minus t cubed, or t to the power of 3 over 3 minus t squared over 2 plus 3t plus C. Then we can have, so we can rewrite this as 12t to the 8 over 8 minus t cubed over 3 minus t squared over 2 plus 3t plus c. However, if you don't like to see terms in this form, we can still rewrite this as 12 over 8 t to the 8 minus 1 over 3. Again, they are just the same. T cubed minus 1 half t squared plus 3t plus c. We can simplify these since both are divisible by 4. So the 12 divided by 4 is 3. 8 divided by 4 is 2. Then we have t to the power of 8 minus 1/3 t to the power of 3 minus 1/2 t squared plus 3t plus c. And this should be our final answer. And by the way, do not be tempted to combine all these terms here because variables or letters that have different exponents cannot be added. So please, 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 please do not combine variables of different exponents if the operation is subtraction or addition. So let's check Paul's answer. If we have the same answer, please, please, please make it correct. Okay. So we have here. Okay, let's move. Okay. So we have 3 over 2 times t to the 8 minus 1 over 3. Alright, apologies. So I write 3 here, but my answer here is 3. So that should be 1 over 3. T cubed minus 1/2 t squared plus 3t plus c. Alright, and that's it. And I guess I think I can solve one more problem. So if you want, just comment which problem should I solve. This will be my last solution for tonight. I think so. So will it be 4, 5, 6, or 7? Okay, I think I'll solve number 6. So let's try to solve number 6 since it's new to the eyes. So it says that I'm not good in writing using mouse. So it says that we have to determine or find, some would use the term find f of x, given that f prime of x is equal to 6x to the 8 minus 220x to the 4th plus x squared plus 9. Now, if the given is this one, that means this whole form here is a derivative of something. Now, if it's a derivative of fx. So since we need to find f of x, so which means if this one is derivation, so the opposite of the derivation so that we can find f of x is integration. Because f prime of x is the differentiation of f of x. On the other hand, or in the reverse, f of x is the integration of f prime of x. So which means this can be rewritten as 6 to the 8th minus 20 x to the 4th plus x squared plus 9, and all of these terms are differentiations or derivatives. And since we need to find f of x, that means we will need to integrate these terms. So if we rewrite it clearly, so I'll have to rewrite it here. So this will become 6x to the 8, apologies, to the 8 minus 20 x to the 4th plus x squared plus 9 dx. So we can start the integration. So let's integrate them one by one. So that is the integral of 6x to the 8 dx minus the integral of 20 x to the 4th dx plus the integral of x squared dx plus the integral of 9 dx. So we can go back to the properties at the top. We have the here integral of dx is x, integral of a dx is a times x, integral of x to the n, or if this is 2, that's x squared, so that will be x squared plus 1 over 2 plus 1. If this is 7, so that will be x, integral of x to the 7 is x to the power of 7 plus 1 over 7 plus 1. So let's have, but before that, we'll have to move out the constant values. So this will become 6 times the integral of x to the 8th, derivative of x, minus 20 times the integral of x to the 4th, derivative of x, plus integral of x squared, derivative of x, plus 9 times the integral of dx. And then we'll get 6. Let's integrate now. So this is x 8 plus 1 over 8 plus 1 minus 20 times integral of this is x to the 4th plus 1 over 4 plus 1 plus x 2 plus 1 over 2 plus 1 plus 9x. And we should not forget to write c. Then simplifying, let's proceed. We'll have x times 8 plus 1 is 9 over 9 minus 20 times x to the 4th plus 1 is x to the 5th over 5 plus x cubed over 3 plus 9x plus c. There are some terms that we can simplify. So for example, 6 over 9. So both of them are divisible by 3. So this could result to 6 divided by 3 is 2. 9 divided by 3 is 3. Times x to the 9 minus 20 is divisible by 5. So this will become 4. X to the 5th plus 1 over 3. Or you can just write it as is, x cubed over 3. But sometimes, some would like to write in fractional form this one. So it's like a mixed number form. But again, it depends on you or your teacher. So if our teacher would say you have to separate or move out the fraction sign, then we'll have to do that the same one as I write here. But if it's okay for the teacher, then just write it as is. Okay, and since it's now in the simplest form, then this will be f of x. So we now have solved for f of x. All we need to do is check whether we got the correct answer. Paul, please Paul, online's notes. I hope my solution is correct. Check. So the answer is 2 over 3 x to the 9. Yeah, that's correct. So let's change. Okay. Then move. Okay. Then the next is 4 x to the 5th. All right. Then 1/3 x cubed. Then plus 9x plus c. By the way, please be wary of this, or please take note of the signs. Okay. Same, whatever the sign, just follow the signs. Which means our solution is correct. Yay! And that would mean that I am actually good in integration or definite integration. So the topic is about indefinite integrals. So tomorrow, I guess tomorrow, we'll have to move to the next topic. I guess we'll have to answer computing indefinite integrals. Let's check what's within this part here. Let's just open a new tab. So computing indefinite integrals, practice problem. I guess it's just the same with the first part, but more challenging. So you see there are now negative exponents and roots. Oh no. Okay, I think we'll have to solve it today. Just this portion here with negative exponent. Let's try number 3. So this is now 5, 1, 2, computing indefinite integrals, number 3. So just one last. Okay, we have the integral of 10 t to the negative 3 minus or that's plus 12t to the negative 9 plus 4t cubed derivative of t. So always remember that those terms in between the integral sign and the derivative of t are the terms that we need to integrate. So let's solve now. So I hope you are now familiar with the integration rules or characteristics, the first three. So we'll proceed with these. So take note that in the rule, so you have, if we have integral of t to the n dt, so we'll have to add the exponent by 1. Remember, add by 1. Then plus c. But before that, let's write them with this integral signs. That's t to the negative 3 derivative of t plus integral of 12 t to the negative 9 derivative of t plus the integral of 4 t cubed derivative of t. Then move out the constant, so that will be 10 times the integral of t to the negative 3 dt or derivative of t plus 12 times the integral of t to the negative 9 derivative of t plus 4 times the integral of t to the power of 3 or t cubed times the derivative of t. Proceed using this property, right? This property. So this will become 10 times t to the negative 3 plus 1. Since our n is negative 3, so that will be negative 3. Then the denominator is negative 3 plus 1. And we have plus 12 times t to the power of negative 9 plus 1 over negative 9 plus 1 plus 4 times t to the power of 3 plus 1 over 3 plus 1. Then we should not forget to write c. The next step is, so we've got, need to simplify t. So what is negative 3 plus 1? That is negative 2. So same with the denominator, negative 2 plus 12 times t to the negative 9 plus 1 is negative 8 over negative 8 plus 4. So our exponent here is positive. So this will become times t to the 4 over 4 plus c. Then we can simplify this. What is 10 over negative 2? That is, do not forget the sign, that is negative 5. Then we have t to the negative 2 plus we have 12 divided by 8, so that both are divisible by 4. So this is 3 over negative 2, right? Then t to the negative 8 plus 4 divided by 4 is 1. So that will be t to the 4th plus c. I will just need to rewrite this since we have negative here. So this will become negative 5 over t to the negative 2 minus 3 over 2 times t to the negative 8 plus t to the 4th plus c. There, it's all right if we stop it here. So my teacher will accept this, commonly accepts this answer. But if you don't want to see any negative exponents, so we'll have to change this one. If we recall, in the rules of exponent, if we have a to the negative 1, that is just equivalent to 1 over a, which means if we have a to the negative 2, that is equivalent to 1 over a to the power of 2, or a squared. Or again, we can rewrite this if you would like to. This will become negative 5 times 1 over t squared minus 3 over 2 times 1 over t to the 8 plus t to the 4th plus c, or you can combine. This will become negative 5 over t squared minus 3 over 2 t to the 8 plus t to the 4th plus c. Then again, so we can stop in this part here. But let's check first if our solution is correct. Let's check the answer according to Paul. All right, we have here negative 5t. So look at this, negative 5t squared. So this is correct. Then we have minus, get it right, 3 over 2t to the negative 8. That's correct. We have t to the 4th and c. And we got the correct answer. So that's it. This is now this is the first part of my review in math, especially calculus. So tomorrow I think I'll continue solving, but the problem would be now on I'll continue substitution rule for indefinite integrals or computing indefinite integrals, because there are problems such as square root, cube root, fifth root. Then we also have products. Then we also have sine, cosine. So these are now different properties. We have cosecant and exponentials. So we'll try to solve these tomorrow. So hope you will be with me also tomorrow. Thank you, everyone. Thanks for watching, and see you soon.